On today's episode, are heat pumps the answer for clean heat? Well, it depends. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Well, up here in the Northeast, it's heating season again. Now, it might be natural gas or propane or oil heat, but for most of us, it's still about burning fossil fuels. And of course, this is a serious problem for climate activists, and right on cue, climate change spokespeople are all over public radio to excoriate those of us who burn carbon to stay warm. Now, from the household perspective, however, few Americans or Europeans can get by without some kind of space heat, and a heavily promoted and purportedly environmentally friendly solution is the heat pump. Now, as you engineers know, they operate with the reverse Carnot cycle, and they can be highly efficient under certain circumstances. Compared to heating by electrical resistance heaters, for example, a heat pump can deliver 4 times the heat energy relative to the electrical energy required to operate it. Now, in an ideal world, that's great, but heat pumps are still subject to the basic physics that affects all heat exchangers and heat transfer processes. Heat transfer rates are directly proportional to the delta T across the heat exchanger to ambient interface. To heat a home in the winter, the pump essentially operates as an air conditioner attempting to refrigerate the already cold outside air. And the colder the outside air, the lower the delta T and the lower the heat transfer efficiency as a result. Now, to get around this, newer heat pump technology includes flash injection modified refrigerant loops and variable speed compressors to keep generating heat at temperatures as frosty as 25 below zero, although these systems are expensive. Now, in cold climates, a conventional heat pump will frequently be a booster for a regular fossil fuel furnace or boiler. From an energy standpoint, heat pumps will reduce your carbon footprint, but from an economic standpoint, it's not quite so clear. If a homeowner is replacing a worn-out fossil fuel furnace, for example, unless the house can be sufficiently insulated and the heat pump chosen sufficiently efficiently, it will still be necessary to have an auxiliary heating system, and if that means a new furnace and a heat pump, the economics can be pretty doubtful, especially in this era of high interest rates. Now, it's different if your location gets very hot in the summertime because heat pumps can work in reverse and act as an air conditioning system. In that case, the opposite can happen, where replacing a broken central air conditioning system with a heat pump can lower winter heating bills, although most pumps are significantly more expensive than air conditioning units. So where should the average homeowner spend the money? Now, the physics and the mathematics suggests that the low-hanging fruit is always insulation and draft control. So if your windows are old and leaky and there's nothing but shredded newspaper in the attic, you have bigger things to think about than the machines in your basement. Can a $10,000 heat pump generate a return on that investment at current prices for natural gas, propane, or heating oil? Well, that depends too, with a major factor being the length of time you expect to remain in your home. Now, I've run the numbers, and in my home, the most cost-effective solution is new windows plus a new, very high-efficiency gas furnace. Your mileage may vary. It's a complex choice, but one thing's for sure, unless your home is already as airtight as a mason jar, insulation is where the first dollar should go. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.